19 review. Number 5. A hypothetical survey, is carried out by the finance department to determine the distribution of house sites in a certain city. They draw a simple random sample of 1,000 households. After several visits, the interviewers find people at home in only 653 of the sample households. Rather than face such a high non-response rate, the department draws a second batch of households and uses the first 347 complete interviews in the second batch to bring the sample up to its planned strength of 1,000. The department counts 3,087 people in those 1,000 households and estimates the average household size in the city to be about 3.1 persons. Is this estimate likely to be too low, too high, or about right? Okay, so I'm going to write this out. Maybe it'll make it easier for you to understand. So they pick 1,000 households that they want to survey. They go there. Most people, so 653 of them actually had people at them when they showed up. Hello? The gym. In the gym. Sure. All right. So 653 were at home. So rather than face such a high non-response rate, the department draws a second batch of households and uses the first 347 completed interviews in the second batch to bring the sample up to its planned strength of 1,000 households. So they create another group, and we don't know how many are in there, but the first 347 houses that they find people at home, they stop and then combine those into the 1,000 they wanted. Wow. So the department counts 3,087 people. So 3,087 people among the total 1,000, and they say the average household, divide that out, is 3.087, which they round up to 3.1. First off, is this a good idea? Probably not. Why? Okay. Are these people going to be relatively the same or quite different from these people? They're probably going to be the same. Okay. When are you going to come pick that up? Okay. Okay. I'll leave this door open for you. So these people are going to be about the same because they were home when the interviewers decided to go out and conduct their research. So does adding more of the same people to the survey help? Not really. Okay. There were 347 people in this group that didn't get contacted. Are these people and these people the same or different? They might be different. If they're the same, we don't really care, right? If they're the same, then our survey worked and we don't need to worry about it. But there is a chance that they weren't home for a reason. What could those reasons be? Okay, they might be students, they might be at work. What else? Okay, maybe they were at church. Maybe they've been arrested. That's true. Okay. You can't be home if you're in jail. Okay. So, there's another reason why they might not have found anybody at home. And it has something to do with the question that it's asking. Is this percentage too high, just right, or too small? Why too small? I'm going to say too high. Why would I say that? Okay, what if there's only one person living in the house? If one person lives at the house, what are the chances you're going to find that one person at home? Depends on what they do, but if 6 people live in the house, what's the chance that you're going to find at least one person at home? Pretty high, right? So my guess is that there are a lot more single people in that list or smaller families in that list. Does that make sense? And because of that, these people, and by extension those people, because as far as we know they're the same, those must or probably had larger families. And if one person is at home, that one person, I mean, even my 5-year-old could say there are 6 people in my family, right? And as long as they catch one of them, then they'll get the number they're looking for. So my guess is this number is probably a little bit too high because those smaller families are harder to catch at home. All right. And guess what? You'll never know if I'm right or not. That one seemed pretty straightforward, though. Ooh, ecstasy was a popular drug in the 1990s. It produced a sense of euphoria, derisively called yuppie high. One investigator made a careful sample survey to estimate the prevalence of drug use at Stanford University. 2 assistants were stationed on the main campus plaza and instructed to interview all students who passed through at specific times. As it turned out, 39% of 369 students interviewed said they had used ecstasy at least once. Does the investigator's procedure give a probability sample of Stanford students? Is standing out in the college quad asking people a probability sample? No. No, when you go to college, um, when you take your general classes, you might be all over the place. But the further you get into your college, the more likely you are to be segregated to one specific building or maybe one part of campus, and all your classes are right there, right? The math people have their building, and the biology has a building, and the English has a building. So standing out there is not a very good way to get random students. Also, some people take morning classes, some people take night classes. Um, People who are on ecstasy probably don't get up super early. You know, they're raving in the nighttime. Anyway, there are lots of reasons why that's a bad idea. Also, is it a good idea to just ask a bunch of strangers whether or not they use illegal drugs? Probably not. Yeah, they're like, no, I've never done that. Not a good idea. Um, some sort of secret ballot or anonymous method would probably be a better idea. So, would you guess that 39% is too high or too low? Probably too low. Okay, unless maybe they had a hello. Maybe there was some sort of rave or something that they were looking into. So, anyway, my guess is it's quite low. And then number 9. One hospital has 218 live births during the month of January. Another has 536. Which is likelier to have 55% or more male births? Or is it equally likely? And by the way, there's a 52% chance for a live birth infant to be male. So in our box, oops, I didn't want to do that. Oh well. in our box, um, of all births, the males make up 52%, and the females make up 48%. And we also know that by like age 5, they're equal. So for some reason, male babies don't have the same survivability as female babies. And after that, you know, in the teenage years and later, it gets even worse because males aren't always the brightest. So we have two different groups. We have one group that has 218 births and one that has 536. Which one is more likely to report a male birth rate of 55%? The 218. Why? It's a smaller group. So when your sample size is small, your percent error is likely to be bigger. When your sample size is large, your percent error is likely to be smaller. Okay, now let's flip it. If your sample size is small, your chance error is smaller, and when your sample size is large, your chance error is larger, which is weird. The more you draw, the higher your chance error gets, but the lower your percent error gets. How do we explain that? What makes the chance error go up, but the percent error to go down? The error is growing slower than the denominator or the number of draws. Okay, now I know we've said that 100 times, but it's not going to go away. And then the last one was 12. Cheating is pervasive. Nearly 80% admitted some dishonesty, such as copying someone's homework or cheating on an exam. The survey was sent to 5,000 of the nearly 700,000 high school achievers included in the 1993 Who's Who. The results were based on 1,957 completed surveys that were returned. The surveys do not pretend to be representative of the teenagers, said Who's Who. Students are listed in Who's Who if they're nominated by their teachers or guidance counselors. 98% of them go on to college. Why isn't this survey representative of all teenagers? It's not random. How did they get in? Somebody picked them. Anytime there is people, anytime people, all right. Is the survey representative of the nearly 700,000 high school achievers included in the Who's Who among American high school students? So no, why not? So it said the survey was sent to 5,000 people. How were those 5,000 people chosen? Well, okay, so 700,000 people are in the magazine. How were the 5,000 of them chosen? We don't know. Doesn't say. Okay. And 1,957 turned their surveys in. What about the other 3,000 people? We don't know that either. So we could have some non-response bias, right? Some kids, a lot of kids who cheated maybe didn't want to admit that, or maybe the kids that cheated wanted to brag, so they turned it in. There are lots of problems that we could see there. Okay, done with chapter 19.